This one is a little bit trickier because there are two parts to it. It's very similar though, right? The first part says to find x, which we have, and the second part is to find all of the angles and all of the sides. So let's start by finding x. Label the side you know. Well, we know 5.6 kilometers. We're given that length. Now label the side that you want to know, which is x. So this one, the 5.6 kilometers, is, do you notice that the right angle is here and this side is next to, sorry, not the right angle, the angle that we're talking about is here and this one is next to the angle. It's next to the 70 degrees. If it's next to it, that means it is adjacent. That's what the word adjacent means. It means next to. Now we'll label the side we want to know, which is this one here. Compared to this angle, it's not adjacent. It's not opposite, because that would be this one. It is the hypotenuse. It's the longest side in this triangle. Another way to notice that it's the hypotenuse is that it doesn't touch the right angle. It's on the other side to the right angle. Okay, so now we can look for a formula. Our formula is going to have adjacent and hypotenuse. Not that one. That's opposite and hypotenuse. This one. That one has adjacent and hypotenuse. So let's write the formula. Cosine theta equals adjacent over hypotenuse. Now we'll replace theta with the angle. So we'll replace theta with 70, because that's the angle we're talking about. That's going to be a fraction. The top of the fraction, the numerator, is the adjacent side. And the adjacent side here is 5.6. The denominator, the bottom of the fraction, is the longest, it's the hypotenuse. And the hypotenuse in this diagram is x. Now, we've got a fraction here, and x is on the bottom. We can cross multiply. This divide by x will move to the other side and turn into a times by x. So it will be this number multiplied by x. Divide by x on this side turns into a times by x on this side. And that equals 5.6. Get it closer. You might notice that this question is a bit different to the ones on the last page. Here, it happened that x was on the bottom of the fraction, whereas in the last page, x was on the top. So there'll be one more step for us. Because now I don't have x by itself. I've got x times some number. So this here is a number, and I know what x times a number is. But I want to undo that. I want to figure out what x is. Well, this multiply by cosine 70 degrees. What's the opposite of multiply? Divide. So it will turn into divide by cosine 70 degrees. Do you see that? This whole blob here, this whole thing has been multiplied by x. X times this thing. So in the next line, it moves to the other side and turns into a divide. Now you can put that in your calculator and you'll get an answer, which you can round to 2 decimal places and use the approximately equal sign. And then, what unit here? This is a length because I'm figuring out how long this is. And the length, the unit is kilometers. About 16 kilometers. I suppose that makes sense. If this is about 5.5 kilometers, then yeah, this looks like it could be 16 kilometers, just eyeballing it. It's a lot longer. Now that we've figured out this length, well, let's go on to part B and figure out all the other angles and all the other sides. We'll start by maybe figuring out this angle here, although it doesn't really matter which order you do this in. I want to figure out, we know what this angle is, that's great. We know what this angle is. This angle is 90 degrees, you can tell because of the square. But we don't know what this angle is. This one right here. So because we want to figure it out, we're told to figure out all the angles. Let's give this angle a letter. I'm going to give her a letter that is the Greek symbol alpha. That looks like an A, but it doesn't really matter what letter you give it. So now we can figure out this angle, and we don't even need trigonometry for it. Because look, the angles in this triangle are alpha, 70, and 90. But these are angles in a triangle, and angles in a triangle add up to 180 degrees. So alpha plus 70 plus 90 equals 180. When you add those three angles together, you should get 180. Did I say 190? 180. Cool. Now all we need to do is solve the equation and we'll have found the last angle. To solve this equation, there are a few ways you can do it. One way is to recognize that this here, 70 plus 90, is a bit of arithmetic. We can figure out 70 plus 90 is 160. So I'll just replace it with 160. It's the same number, right? And that equals 180. Now that plus 160, I can move to the other side. The opposite of adding 160 is subtracting 160. 180, take 160 is 120. By the way, once again, I've forgotten to put my therefore signs on these two equations here. The reason we have therefore is because if this equation is true, therefore this equation is true. So because the first equation is true, the second one has to be true. And because this one is true, the next one has to be true. So we've just proven that the angle is 20. Not just 20 though, we need a unit. What's the unit for this angle 20? The unit, of course, is degrees. Neat! Okay, so we've done that. It does say to find all other angles and sides. We've definitely found all the angles. We've found this side that was told to us. We know this one. Sometimes it's useful to write that on the diagram. So once you find out a piece of information, it is probably easier for you if you write it on the diagram. And that will help you for later. So that angle at A, we know, equals, apologies for my dodgy little handwriting here, 20 degrees. Okay. We know this side, we know this side. We don't know this side here. So let's give it a letter so we can figure it out. I'm not going to use X for this side here. Can you guess why? That was not a pun, by the way. The reason is I've already used X. So let's use something else so we don't get confused. Let's call this Y. You know, why not? So now we can use trigonometry to figure out this. To find Y, and let's, describe what we're doing now, find Y. We can label the side that we know, the side that we want to know. One side that we know is this one here, and that, compared to this 70 degrees, is still adjacent. And the side that we want to know now is Y. So this one here is the one we want to know, and that is opposite this angle. I'm just going to clear a whole bunch of stuff off the screen just to make it easier. There we go. So I've got this angle here, and Y is opposite. It's the side that is on the complete other side to this angle. It doesn't touch the angle at all. Okay, so Y is opposite. Now we're looking for a formula that will link these together, opposite and adjacent. Which of these three formulas involves opposite and adjacent? It's tan theta. So tan theta equals opposite over adjacent. We just copy down the formula that we're going to use. In the next step, we can replace theta with the angle. The angle was 70 because we were looking at this angle here, 70 degrees. Equals, I'm not going to forget to put my therefores, by the way. I'm going to do that right now. Line. Opposite on the top. So opposite this is Y, the side we want to know. And adjacent next to this angle is 5.6. So tan 70 degrees equals Y over 5.6. Now I want to get y by itself, so I really want to get rid of this divide by 5.6. And you can cross multiply. It moves from the bottom of this side to the top of that side. It goes across where it turns into a multiply. The other way of thinking of it is that the opposite of dividing by 5.6 is multiplying by 5.6 on the other side. So therefore, 5.6 times 1070 equals, what's the only thing remaining on this side? Just y, that's the only thing that's left. And if you put this in your calculator, 5.6 times tan 70 degrees, you should get an answer that's approximately equal to 15.39. I should have a unit on this. Y is not an angle this time, but a length. It's the length of this line here. And the unit is the same as the other one. It's in kilometers.